Hi, I'm Paul Harland, a Solutions Architect here at Snyk, and today I'm going to take you through the Hack and Fix tutorial. Now what you're about to see is a moderately skilled programmer attacking an intentionally vulnerable application. But far from being futile, this exercise is valuable because it will help you put a face to the name from some of these weaknesses. XSS or cross-site scripting, remote code execution, directory traversal, all easy to enact but devastating if performed on a live application. We'll also show you how to use the intelligence from the Snyk platform in order to identify and remediate these vulnerabilities. And most of all, we'll also teach you how to be able to learn and perform this demonstration to your customers, therefore being able to show the power of Snyk to all your future opportunities. So the agenda for today is we're going to set up our demo environment which will contain this vulnerable application. We're going to run that application and then identify and exploit some vulnerabilities that we know are there. We're then going to scan the application using Snyk, and we're going to use that intelligence in order to be able to patch and fix that vulnerability. Then we're going to re-show that we can no longer exploit that application with that initial vulnerability. Now you can try and follow along today, but we might be moving quite fast. So there is a course going to be available on the partner portal, and we'll be sending out invites to that after the session. So the first application we're going to look at is the OWASP Juice Shop. Now, as mentioned before, this is an intentionally vulnerable application used for education and demonstration of some of these vulnerabilities. So what we want to do first of all is create a copy of that application for ourselves. So we go over to GitHub where this is hosted. And we can see here there's some information about the application in the README which tells you all about it and how to go and learn some of these vulnerabilities yourself as well. First thing we want to do then, as I say, is make a copy ourselves. So we copy the URL, we go over to Bitbucket where I host my repositories, and we create a new repository. In this page we simply put the URL for the existing repository here, import. And then we import that repository. And we're going to make a copy ourselves which we can change and fix some of those vulnerabilities. Now there will be some pauses as some of these processes actually complete, so I'll try not to fill that with incessant ranting. But what we'll do after this is we'll make a local copy of this repository and run the application. Almost forgot, I need my hacker hat on in order to perform this. Okay, so now we've made our copy, what I can do is receive the URL and clone this to my local machine. I've already set up my SSH key, so this is going to be a relatively easy process. So if I copy and paste that git clone, we'll then pull that down from GitHub to our local machine, and we can then build and play with that code. Okay, now that we've cloned the repository locally, we'll go into the directory and we're going to install the application. This will take a few minutes, but it will complete. Okay, now that the application has built, we're ready to run the application and view the website running on our local machine. So I'll type npm start. You can also see that I need to update my npm, but that's another story. Once this has started, the server will be running locally and it will give us a URL where we can go and visit that website. Here we have the message that the server is now running and available on port 3000. So let's go and visit that URL. Here we load up the Juice Shop application. It's a single page application with the front end in Angular and the back end in Node.js. And if we go to a different URL, which is the scoreboard, we can see that there are actually a number of challenges, one of which we'll perform today. But if you have more time or more inclination, you can go through and actually solve all of these challenges and learn a bit more about hacking applications. So let's have a look at cross-site scripting. If I go to my slides and present, you'll see that cross-site scripting is a particular type of vulnerability where the software doesn't neutralize or sanitize the user input before it's placed to the output. So if I can send you a URL or some code on the end of the URL, the application will forget to sanitize that and actually run the code in the URL that I've sent you. Therefore, I can start to do things and change that application so it doesn't behave as the actual owner of that application wanted it to behave. Now, what type of cross-site scripting or XSS vulnerabilities are there? Well, there are quite a few, but we're going to name three here. The first one is the stored attack. That's when the attacker actually takes hold of a vulnerable or compromised server. This causes the website then to deliver malicious code. Now, this is a one-to-many attack, so it's the most dangerous because once you've taken control of that server, it will continue to deliver malicious code to every subsequent visitor. This means that you can take hold of the details that the visitor is adding into form fields, username, email address, possibly password and payment details as well. So this is a very dangerous one that takes hold of the server. The second type is reflected attack. This occurs when the payload that's stored in the data sent to the browser can still affect the server. This is again a one-to-one type though. But what happens here is the attacker typically sends the victim a custom link and that directs the unsuspecting user towards that vulnerable page. And then they can use a variety of techniques to get the details from that visitor. The third base is DOM-based. Now that's when the server itself isn't actually involved in this vulnerability, but the vulnerability is enacted entirely within the JavaScript of the web application. Because JavaScript is used to add interactivity to that page, if you augment a URL and add some code in there or add some HTML in there, you can actually change what the visitor sees once they've performed a search function, for example. An example of that is really being able to change what they see, possibly redirecting payment details to a different payment provider, which is not the intended one of the web application. Let's go through now and do an example of this DOM-based XSS vulnerability. So if I go back to that application and use the search box, and instead of using the search box to look for a product, I can inject some code. Now what I'm injecting here is a little bit of HTML, which inside it creates a new iframe and then says, can you javascript.alert, and we'll get an alert on the page that shows the text XSS exclamation mark. And you can see here that that's happened. So this code has actually been run by the application and is outputted. Now that in itself, is not a major problem because we've not changed the application. But what we could do is we could craft a link that actually changes the underlying application, and that could potentially send you to a different payment provider so that you're paying not the website owner, but the person who sent the malicious link. We could also have some fake products on the website. So as you can see, this is one vector of attack that can cause a lot of problems. And it's usually the user of the application which befalls to that vulnerability. Okay, so now that we've done the vulnerability, let's go and look at that in Snyk and see what information the Snyk application can give us about this. So the first thing we need to do is import this project to Snyk. I'm going to import that from Bitbucket. So if I add project, I can go to my Bitbucket Cloud integration, and I'll get back a list of all the repositories that I can see with my particular credentials there. I'll click on Juice Shop and then we'll scan that application. Now what we're doing, we're going over to Bitbucket, we're using the API in order to look at that application and give intelligence to all the different layers that Snyk looks at. So that's the developer written code, the open source code, any containers or Docker files, and any infrastructure as code files as well. Once that's complete, we'll then have a list of different reports which give us the intelligence on each of those different layers. If I then filter this by my Bitbucket Cloud, you can see that we've got the Juice Shop scans done already. If I open that up, you can see we've got the code analysis. So that's the SAST scan on the developer written code, which is what we're going to look at today. We've also got the scan on the Docker file run, so the container vulnerabilities are there. And we're still completing another scan at the moment. I think that will be for the SCL or the open source code, but we're not looking at that just now. So let's click on the code analysis. So the code analysis report is very similar to all Snyk reports. It's organised by the Snyk priority score, which you can see here is 903 for this top item. It's then grouped into the different CWEs or common weakness enumeration classifications, so you can see the type of vulnerability that we've found in that code. So we've found some cross-site scripting, which is what we're looking at today. Quite a lot of those, prototype pollutions, regex DOS. And we've also got down here some hard-coded secrets. So there's lots of different vulnerabilities that we've found. A particular one we want to address today is a cross-site scripting, and we're looking for that search function. Where is the code that handles or deals with that search in the top corner? Now you can see here this second one actually looks quite interesting to us. Here we've got sanitizer bypass security trust HTML, and we're actually passing some code into that. And these are results that we get from the search function. So that could be interesting. If we look at a bit lower, actually, we can see that we've got query param. Now, query param is taken after the hash, or the question mark, sorry, on the URL. So that's very interesting to us. This then also passes it into search value. So this looks like the one that we are actually finding and exploiting in our code. So let's go into the full details and find out a bit more about this one. So here you can see CWE 79, so it's the correct type. We can use the taint flow analysis on the left to actually drill through this vulnerability in our code and see actually how it's enacted from start to finish. And once that query param is passed through, it ends up in this sanitizer bypass security trust HTML. That in itself doesn't sound like a very secure method to use. So I think this is probably what we want to do to go and address that problem that we've found. What we can do is go over to the fix analysis and learn a bit more about this type of vulnerability. Here Snyk provides some educational content and to what types of attacks are present from cross-site scripting, which is what we talked about before, except for mutated. Also how to prevent these in future again. It's no point in just showing the developer how to fix a particular vulnerability. The education's there to prevent them doing it in the future as well. And over in the right hand side, you can see we've actually picked examples from good open source projects on how other people have solved similar problems. So we can get some idea about that as well. Now in this particular case, I know how to solve the problem. So what we'll do, we'll go through to that file. If I click here and open a new tab, we're going to open that particular file in Bitbucket, and we're going to be able to see those functions which have got that security bypass method attached. What we can then do is address and fix those vulnerabilities and then retest that program. Okay, now that we've got our file open in Bitbucket, we can find out which line Snyk was pointing us towards, which is 152. And we can go and find that offending line. So here you can see we've got this sanitizer bypass security HTML. So what's happening there is it's trusting everything that gets sent through that search box and pushing that back out to the search results page. So what we want to do is intercept this, start to sanitize the input and make sure that there's no code that can get executed on the page as it goes through. Now we can do this over in Bitbucket with this useful edit function here, where we can actually go into the file and edit the offending line. Oops, give me a second. But this is just one workflow and one way to do this within Snyk. What we can also do is use the integration into Visual Studio Code. Here you can see I've got the same Snyk plugin used, And we've identified in this same search results component file two unsanitized inputs from HTML, which is the same as what you got on the web interface, but developers will be more used to this kind of interface and will probably enact the fixes here. So what we want to do first is find this line, and we want to create a new method to use in order to actually make the input from the search box unvulnerable. So what we actually do here is we create a brand new function called Sanitize Html. Now in the example from the course, it will tell you automatically, give you the actual code to do here. But all we want to do is add a new method. So we'll call it Sanitize, American spelling, HTML. And we want to pass some text into that. Okay, so then we want to get var element equals element. So we're going to create actually a DOM element. And we're going to pass the actual text from the search box into this. Okay, then once we've got that, we're actually going to return the inner HTML from that, and that means it will be nice and sanitized. Oops. So now if we use that function, instead of what we had previously, we'll be able to actually sanitize that input. So I'm going to replace this sanitizer bypass security trust HTML with this Sanitize HTML. Just save that file. And because we've got two different versions of this that we need to fix, let's click onto the next one and do the same there. If I use this to go to the last line of the taint flow analysis, I can see we've got another introduction of that there. We'll pass that through to our same new method. Then we will save that, rebuild, and then try that vulnerability again. Okay, the sharp-eyed among you would notice that I did actually make a mistake in the spelling of Sanitize HTML here. That's now been corrected. So now we've made that change, what we're going to do is go back to the application. We're going to stop the application. We're going to rebuild that so that we rebuild all the different TypeScript components. Now it should be a quicker install this second time because we don't have to pull all the open source packages, but again it will take a couple of minutes. Okay, now that we've rebuilt the application, we're going to restart the server. And then we're going to go back to the website and try and do that same hack we did before and see if we fixed it. Hopefully everything worked perfect. So back to the browser. We're going to go to the application. We're going to control F5 so that we reload it without using the cache. Because it's a single page application, the web pages and the actual logic of the application is stored in the browser cache. So here we go. Let's reload the page. Control F5, and then in the search box we're going to type that same code. And there you can see that the hack is fixed. We still get the code passed through, but now it's actually just done as text and the alert box doesn't show. So now we've protected that particular form of input from the XSS vulnerability. Now there are different ways to do XSS vulnerabilities on this application, but we have solved one of them. What I would then do as a developer is go into the Git repository and commit those changes. If we also have a look at Visual Studio Code, you'll see now that the the scan has completed again. On the top here you can see it took 32 seconds to refresh that scan, and those two vulnerabilities in search result component .typescript have been removed. So now we would use all the rest of the vulnerabilities that were found, probably starting from high first, to remove other vulnerabilities that we found in the code as well. But let's also fix these vulnerabilities and push them up to Bitbucket, so we can see that Snyk on the user interface or the web user interface actually rescans and shows those vulnerabilities have been removed. So if we go back and stop the application, we can do a git status and see that we've just got that one file change. So if we do git add and paste that in, we've then staged this file for a commit. And we'll type the message, removed XSS vul. We've now created that commit and we're going to push that up to Bitbucket. So now the changes are up in Bitbucket. Let's go and check that. We can see we've got the latest commit there that we've just added. So that means we can now go and refresh that scan in the Snyk UI using the button here. And we should no longer see that vulnerability now in search result component. Okay, so we've got less vulnerabilities we can see here. Let's scroll down. So we've got track result component, but not search result component. So we've effectively removed that vulnerability and shown it's now removed from the scan in Visual Studio Code and in the Snyk UI. As I said, now as a developer, you go and fix all the rest of the vulnerabilities in that application. So, in summary today, what have we done so far? Quite simply, we've identified, we've proved that there's a vulnerability, we've exploited it, and then we've gone through and fixed it. We've also demonstrated the power of Snyk in terms of identifying these vulnerabilities and showing you how you can possibly fix them as well. And as I've said, if you've not managed to follow on this first example, you can go on the partner portal. A course will be assigned to you where you can go through each and every step and learn how to do this yourself. Okay, so for the second application that we're going to hack and fix, we're going to use the Java goof application. Now this application, again intentionally vulnerable, was written by Snyk. And we're going to enact the remote code execution vulnerability that we find through the Apache Strut's open source piece of software. So for our first hack, we were using a SAST tool to look at the developer written code and find weaknesses in that developer written code. For this second hack, we're using SCA, or source composition analysis, to look for vulnerabilities in the open source code that cause these vulnerabilities. So again, the first thing we want to do is go and fork that repository. So we go over to GitHub where Java goof is stored, and then we can copy that URL and go back over to Bitbucket again, create a new repository, again importing this repository, put the URL in there, choose a project and import the repository. Now we're going to create that copy, and then what we're going to do is pull that locally and build and host that on our local machine. What you will need on this machine to do this hack is Docker Desktop, as we're going to use Docker Compose to bring up this application. So once we have this, we can again copy the URL to clone it. Okay, and I'm going to paste and clone that now. So just take a couple of seconds. And what we're going to do is use this Docker Compose, as I mentioned, to actually bring up this application. Now, as standard, the Docker Compose file comes with 8080, 8080 as the ports for the container to speak to the machine. I will have to change this as I have something else on port 8080. You may well not have to change this, but I do in my case. And then what we're going to do, we're going to go to where that file is stored and enact Docker Compose. Okay, so now I'm going to go to the directory where I've already got this downloaded rather than this fresh one, into my Stranger Danger folder where I keep a few of these resources. And you can actually see, this is a trick of the trade, I'll have vulnerable and fixed versions of the same application. If you're in a demonstration, sometimes it's useful to have both so you don't have to wait for the rebuild, as that can take a few minutes and really ruin the flow of that demonstration. So we'll go through it today, but you may want to have two different versions of an application that requires quite a lot of build like this. Okay, so if I go into the Java Goof application and then I use my Docker Compose up build, we'll actually build that full application and then bring up the server so that we can then view it in the browser from localhost. The application has now built, so if we visit the URL on our browser, localhost 8083, you'll see we're taken to the home screen. Now this is a simple MVC application to manage to-do lists, so it's a working application. If we go and sign up for this application, using some credentials that we've just made up, actually I'll use my real one. You'll see we've got an account and we can actually just use it to create some real applications. So if I go and create a to-do, hack this app, due date 1st of February 1970, better late than never, and you'll see it works as an actual to-do list application. Now the hack that we're going to do first is the remote code execution, and we're going to use a number of tools in our possession. So these are the hacks here that we're going to perform. And all this says is take the contents of Strut's exploit headers, filter for command env, and filter or replace for command env, and then send that over to this URL. So the 8083 is what's going to hit the server, and we're going to see what gets returned to us from that. Let's just take a look at the contents of the Strut exploits headers. Now this is meant to be a normal headers string, but as you can see, what we've got is content type, then we've got some parentheses with what looks like code in between. Now it's not important that you know exactly what's going on here, but just know that we're actually trying to send some code for the server to pass, which it should reject. But in this case, it's not actually rejecting that code. And together with that command, what we can do is try and hack that server. So let's open up a new window here. I'm going to have to use git bash because I'm on my Windows machine. PowerShell doesn't have access to sed. So I'm going to copy this line out here. I'm going to go to the correct directory first, actually. And I'm going to paste that command in. Now what we're going to do, we're going to create a stream using cat out of this file. We're going to pass that into the sed command, which is going to replace the word command with env. And then we're going to hit that server, which is in this case on my local machine, but could be anywhere. And we're going to see what gets returned. Now here you can see we've got lots of information about that server. What should get returned is just an HTML page, but because we're executing that code, we're actually getting some information that we shouldn't know about this server. Now this can be used by a skilled programmer, probably not me, in order to understand and therefore work out what we can do to get hold of that server or control that server as well. And what we can do, we can use a number of different commands that will look at different parts of that file as well. So if we use the second command here, we get a different filtering on the information that's coming, and we've got a full list of what's in that password or PSWD folder. Now this can let us know, first of all, what users are available, what they have access to as well, and can really help us understand how to perhaps take hold and take control of that server. Okay, now that we've demonstrated that the application is vulnerable, let's go over to Snyk and actually scan that application. So again, we're going to import it from Bitbucket. Going to choose the Java Goof app, which we've just created. And again, we're going to perform those same scans. So a SAS scan, an SCA scan if there are any Docker files, and any infrastructure as code files, we're going to perform those as well. So if I open up here, you'll see we've already completed the code analysis scan. Let me just refresh now to get the rest. So there we go. We've got 6 in total scans. So we found the developer code, so we've done a SAS scan. We've got 3 open source scans relating each to their own pom.xml, and we've found 2 Docker files within there which we've scanned as well. Now, because we're looking at the SCA, we're going to look at the pom.xml scans, and one in particular was the Apache Struts vulnerability which we're looking at. So let's start with the to-do list web struts. Sounds like a good place. So if we open up that file, what we're going to see is the report that we generate when we do an open source scan. Here you can see the vulnerabilities on the right hand side organized by the Snyk priority score. So the most important, the critical vulnerabilities are at the top, always showing the developer the next best action to perform. And in this case, it will be to fix this particular vulnerability here. But today, we're not actually acting to remove vulnerabilities from the top down. We're looking for a specific vulnerability. For this, we would use the search at the top and look for remote code execution. And we can see here, we've actually got 3 results back. So that means this piece of open source software has 3 different types of remote code execution. Now, we don't know which one is responsible for the actual vulnerability that we've just enacted now. But we can look here and see, actually, we're using the same version of Apache Struts in all 3, and we're given remediation advice where the individual item is fixed. We've got 2526, 2517, and 2522. So what we could do is we could start with the oldest first. A developer would do that to increment the changes as small as possible to make sure that there was no breaking change or the least possible breaking changes. Or we could just jump straight to the latest and see, actually, if we fix all 3, will our code still work? Will our integration and unit tests still pass and the application still work? So possibly for this one, what we might want to do is fix to the latest version here and remove all 3 of those vulnerabilities. To do that, I would click the Fix This Vulnerability button. This would directly go, first of all, to an interim screen where I could choose which items are added to that pull request. So we've just got the one fix, which we've selected on the previous screen at the moment, but I could easily add extra items into that pull request. I'm not going to do that now. I'm going to do an atomic commit with just this one change. Scroll to the bottom and click Open that fixed pull request. What we'll do at this point, we'll head over to Bitbucket because that's where the repository is held, and we'll create a pull request with some information that developers want and need. So first of all, the developers would see what this change is doing. We're updating Struts 2 core from 2320 to 2526. The developer also has a link to the Snyk vulnerability database. This means that if they want to have more information about this vulnerability before patching, they can very easily go and do that. So now I can go to the top and I can merge that in. Once that's been merged, I can then go back to my Snyk scan, rescan the project and prove that those vulnerabilities have been removed. More than that, what we can actually do is bring up the application. and show that we can no longer perform that particular vulnerability. So let's just do the retest first of all, and then search for those vulnerabilities. So we've searched for a remote where there was 3 before, we've now removed all of them. Now, this is where we'd go to the application and rebuild it. I happen to, as I've said, also have one that I've fixed. So if I go back to this application and restart the one that I've fixed, and then we can try and do that same vulnerability hack again. We'll see that that is no longer an issue. I mean, you could actually do this fix live, but because the building does take so long with this particular, it's a lot easier to have both running at once and just show the different pom.xml files which prove different parts of the open source have been updated. Now the application's built, it's running and it's hosted on localhost 8084. So if we go over to our command that we passed last time, but this time change the port to 8084 and hit that endpoint, you'll see that this time we no longer execute that code on the remote server. Instead, we get back what is an error page. In this case, we're actually in development mode, so we're receiving the development mode page. But what we would get alternatively is the error page for the website without the developer stuff on. We've proved the hack is no longer available through that route by updating the open source piece of software. And what the real power of Snyk here is, we've just done this for one of the open source components in this project, but because we're checking and looking every day, you're always informed of the latest versions that have no vulnerabilities, and you're always informed of any new vulnerabilities on the existing code as well. Okay, so the third and final hack that we're going to perform today is on the Kubernetes Goof application. And this is a directory traversal hack. Now this one's really good because you can involve some audience participation, it's quite easy to perform and quite visual as well. Now we do perform the initial actions the same as everything else. First of all, we go to the repository, which is held here in one of our sample GitHubs. And what we're going to do, again, we're going to go to Bitbucket. We're going to fork that ourselves by creating a repository and importing it. Once that's complete, again, we'll get the clone URL and we'll clone that to our local machine. And again, we're going to need Docker desktop on our machine in order to run this. And we're going to use the Docker compose command to actually complete and run that application. So once the build has completed, we will be able to visit the website on the URL with the port that is defined in the Docker compose. Now I had to change my Docker compose to port 4006 because I'm using quite a lot of ports at the moment. You may have to do the same, but you just change this value here and it will bring it up at that port. So if I go to localhost 4006, not HTTPS by the way for this particular web application, just HTTP, you'll see again we've got another to-do list. And what we're trying to do here is get out of the web folder or directory that we're in and traverse to different parts of the server that we shouldn't be allowed to normally. Now, the directory traversal vulnerability is CWE22. And what that means is the software actually allows external input to enable us to get out of that directory and go all over the server. This means that we can find things like application code, configuration code, user information all around that server, and potentially use that with another hack like remote code execution in order to take over that server. Now, when demonstrating this particular vulnerability, what I like to do is get some audience participation. So we could ask the people, how can we get out of this directory? A lot of people know // is a way to go up a current directory, the current directory to the one above. So what we usually try and do is say, can we put // in here? But the application is clever enough to understand that we're not allowed to do that. But then we can say, okay, so do we know if there's any statically served pages on this? And if we look at the bottom, we've got the About page. Now, the About page is not part of an application. It's just served directly from the web folder. So if we click on this, we'll see actually we're now in the public folder serving the About.html. So again, what could we do? Could we get out of this public folder? So at this time, someone in the audience will usually say, why don't we do a // there? Now, the application is clever enough to understand what you're trying to do there and doesn't let that through. So what we can start thinking is, can we encode some of those characters in order to get out of that directory? So the next things to try is ... and then %(f), which is the encoded version of a slash. And what happens here is the application's not smart enough to realize, and it lets through the %(f). And here you can see we're now actually at that above the public folder. So we can see everything to do with this application here. We've got the application code. We've got the deployment or configuration files. We've got the README. We've got everything to do with that application. So now we can start to go in there and have a look. Okay, what's in the app.js? We can look at the Docker file. What container they're using. We can also look at the package.json. What open source are they using as well? And the attacker can use all this information to start to understand how this application is constructed and where its weak points are. Incidentally, using an application like Snyk would mean that you're removing these vulnerabilities before the application's even live. But what can we do once we have found them is what we're talking about here today. Now, even more interesting than this, we can start to go even further up that application tree. So we can do .. We can do as many as we want to eventually get to that top level directory. Once we're at the top level directory, we can effectively look at every file and every folder on that server. And then we can start to do things like go to the etc and to the password file. Again, looking at the users, the permissions, the home directories, understanding how we can possibly try and script an attack to this server. So as you can see, it's not a very, it's quite a dangerous vulnerability to have in your applications. And what we want to do now is show how we can resolve this with Snyk. So what we would do again is we'd go over to the Snyk application. We would import that project from Bitbucket. And now we're actually importing that project. Again, what we're doing is looking for all the interesting files that we can find in there. So we're going to find the manifest files, Docker files, any Kubernetes configuration files as well, and do a Snyk code scan on that code. So if I open up this now, You'll see we've completed a few of those scans already. We're just doing some more, so if I refresh, I should now see an updated list of scans. Now that the scan's complete, what we want to do is open up the different reports and show that there's the code analysis report, the Docker file reports, some infrastructure as code reports here, and we've also got the package.json report, which is related to the open source components. So we'll open up that report as we're looking for a particular component that has a directory traversal vulnerability. Again, we can talk about the key tenets of the reports here, which is developer focused, organized by the Snyk priority score so the developer can always see their next best action, fixing critical down to high, but the Snyk priority score also includes things like has a fix got available, what type of exploit is it as well. If it's mature, it's obviously more important to fix. But what we're doing now, we're searching for directory traversal. So you can see here there are two directory traversal vulnerabilities in this package. The one we're looking at today is actually in that package ST, but you probably would want to fix both of them as one's a high and one's a medium. So what we'd do here, we'd see, okay, it's introduced through 024 and it's fixed in 025, which is a minor increment, so shouldn't cause any problems if the package maintainers follow semantic versioning. What we'll now do is click Fix this vulnerability. And again, we're taken to that interim screen where we can craft what that pull request looks like. In this case, we're only choosing the one, so we'll scroll down to the bottom and open that fix pull request. Again, going over to Bitbucket, sending that information with all that pull request with all the information that developers needs, links to further information, and then we can ultimately merge that in. In this time, what I'll actually do is go and merge this vulnerability fix in. And then I can actually go back to that application. I will stop the running application. And then what I'm going to actually do is git fetch just to see if we've got the latest commit already complete. And we can see we've got our new fix by Snyk there. So now I'm going to git pull. And that will mean now I've got the latest code. So now I'm going to build again, and then we're going to test that vulnerability to make sure it's now gone. So now we just have to build the application again. And once that's complete, we can go back to the URL and see whether or not we can traverse the directories. Okay, now that the application's built, we're going to go and try again to see if we've patched that vulnerability. Don't forget, if you did change your Docker Compose file locally, you will have overridden that when you pulled from Bitbucket. So go and change that file again before you bring up your website. Okay, let's go back to this URL. And we will refresh this page, see if we can still get an index listing. Excellent. So now we cannot get that file. So we know now we've patched it. Let's try if we can get the public folder, which we're allowed. Yes, we can, but we can't go above that. So we've now patched that vulnerability, and we've done that using the power of Snyk. Thank you. Well, thanks for joining me on this journey today. It's been quite hectic. We've got through quite a lot. So let's just summarize what we've done. We've actually forked and deployed 3 different applications. Each of those applications has a vulnerability that we've exploited. We've found with the power of Snyk, and we've actually patched and fixed that using the intelligence from the Snyk platform. We've looked at XSS, cross-site scripting, remote code execution, and directory traversal, which are 3 of the biggest vulnerabilities out there. You now know or have that face to the name whenever you hear those types of vulnerabilities being talked about. We've also enabled you to understand how to deliver these demonstrations yourself, but always continue to message Snyk's key tenets or Snyk's unique proposition when talking or giving these demonstrations. That's empower developers. Our reports are developer focused, are prioritized, are given the next best action, so are really actionable by the developers. We've got automated fixes which can automatically deploy these pull requests, so you actually never have the vulnerability in your live application to start with. And our security expertise. Our database is not just made up of information from public databases. We have our security team, we have our threat intelligence system, and we have relationships with white hat hackers and educational institutions in order to find more vulnerabilities as well. As I said, the course will be deployed on the partner portal. All attendees will be assigned to this course as well, so you can go step through step and learn how to do these demonstrations yourself. It's probably not advisable to do all three in one demonstration to a customer or prospect, but you can certainly pick one of them and do a quick 15-minute demonstration along with talking about the main platform proposition. As I've said, if you need any help, just ask. We have solution architects all across the world who would be happy to jump on a call with you and help you bring up your demo environment, help you hone your craft in terms of demonstrating these vulnerabilities as well. So please just give us a shout. That's what we're here for. Okay, please enjoy the rest of SnykCon. I'll see you around in some of the other communications and talks. Yeah, enjoy yourself. Bye bye now.